Alright, so welcome to the hands-on demo of array initialization. So we are going to first run the first example, in which we have an array n of size 5. We set all its values to 0 one by one using a for loop, and then we just print the values using another for loop, which goes again from 0 to 4. So let's run this, and you see that element number 0 is 0, element number 2 is also 0, and so are all the other elements of this array. Now let's say I want to initialize this using the different technique. So let's say I set array n5 to be the values in my program. So let's say I use 32, 25, 10, 12, and then maybe 15. I can also initialize it using this. So I have 1, 2, 3, 4, 5 elements. Let me run this program, and now you can see that I have assigned the values that I was supposed to assign, and this is what I get. Right, now let me see what happens if I maybe try to assign it more than 5 values. So if I try to add a value, you see I straight away get this error. It says too many initializer values, and yeah, this is a problem. So if I try to run this, I will get an error, so too many initializer values. Okay, another thing that I could do is maybe try to assign it 4 values and then see what it does. So this is less than the total number of values, and you can see it has set the last value to 0, right? So I only assigned 4 values, 0, 1, 2, 3, and then the last value has been set to 0. Similarly, even if I try to assign it 3 values, it should still work. Okay, and let's say I put this to 0, and let's see what it does. Sets all the values to 0. Now let me see, it said that I need to specify at least one value. So if I don't specify any values, let's see what it does. By default it seems to assign the all values to 0. I think this is something that you should avoid. I mean, it's possible that for other types of arrays it may not do this. So even though it works, you shouldn't. Yeah, so in this case, if you don't specify the blank curly braces, what it does is it initializes it to non-zero values. So you need to specify at least one value. So okay, so this is our first example. Now let's look at the second example. So in the second example, which is from figure 6.5 of the book, what we do is we define the size using the constant size, using the preprocessor directive define, and we are basically assigning values 2, 4, 6, 8, and 10. So let's first run this program, and you see that the elements are assigned the values 2, 4, 6, 8, and 10. Now let's say I want to change the size of the array. Well, I can just change that to, let's say, maybe 8, and all I need to do is make that change here. If I wasn't using this approach, then I would have to change the size here 8. I would have to change it here as well, I would have to change it here as well. So I would have to specify that in 3 different locations, and if I forgot to do it, it would have been problematic. So so this is very convenient. So just one change and you can see our program is modifies on its own. So you just add more values, so 2, 4, 6, 8, 10, and then 12, 14 and 16, right? So using this type of approach made it very easy for you to modify your program. So that's an interesting thing that you could do. Now let's try something else. Let's try to set the size using an unsigned integer variable, and let's call that size and make it equal to 5. You see that this gives you an error. It says expression must have a constant value. Because this is size this is the size of an array, and you cannot change sizes of an array. So let's say if you write it in the current form, what you could happen is you could go down here and maybe change the size to something else, and that would cause problems in your program. It would call logical errors. So logical errors. So C actually prevents you from doing that. So if you try to do it like this, you will get some sort of a syntax error. And you see the expression must have a constant value. So now should we just be using the define constants here? Well, there is one thing that you could do. If you make this a constant integer, you can see that this disappears. Once this disappears, if you try to run it, now you see that this has started to work. Why? Because we have now made this variable a constant. So when we say it's a constant, then we can what that implies is that its value will not be allowed to change later in the program, and then your program starts to work. You can use either of the two approaches, whichever one you like. Let's say if you're initializing arrays inside functions and you don't want to use like global constants, then this is something that you could also use. It really is up to you and what you want to do. Okay, so let's try one more example. And so this is again this is from the book. So this is example from figure 6.6 of the book, I believe. And now we have an array of size 12. We initialize it to 12 values, and what we want to do is to compute the sum of these values. So we can do that using a variable called total. Initial value is 0, and then we just add or accumulate the values of all elements of the array inside that total variable. And let's see how it works. And so it shows you that total of array element values is 383, which I believe was the same value that you were getting in the book as well. So you can check it from there too. So this example also illustrates some key concepts. Now maybe we have one or two more examples, so let's quickly look at those as well. Right, so let's quickly look at this example where we were counting the frequency or the number of occurrences of the integers from 1 to 10. So this was based on our student feedback or survey example. So we have the values or 40 responses inside the responses array, and we're going to count the number of times that each of these digits occurs. You can see you have 1 and then 1 1 over here, and then you have lot of 6s, and so you're going to count the exact occurrence of each of these numbers, which are from 1 to 10. So if we run that, well, how do we do that? Well, we're basically using a frequency counter array, which is basically called frequency. It has size of 10, and then elements at index 1 to index number 10 of this array will keep track of the number of counts of the numbers from 1 to 10. So if we run this, you can see that 1 occurs 2 times, so 2 students gave a rating of 1, 2 students gave a rating of 2, 11 students gave a rating of 6. You can check that there are much more 6s here. You can count them to be exactly 11 just to double check. So yeah, so interesting example. Play around with this. There are a couple of other examples in the book as well. I would suggest play around with those. Go through the histogram example where it plots the stars as well. Also, I would suggest going through the random example to see, again over there we're doing the same thing, but we are counting the numbers from 1 to 6 because our die actually can have only produce those 6 numbers, but we are doing a bit of a random experiment, so that would be a useful example to try out. Alright, so that's it. Thank you. I will see you in the next video.